Okay, our last section of Unit 10, this is Lesson 13, this is inequalities. So really considering what's going on in the numerator and denominator. So we have the rational inequality in exercise 1. We need to find what x value is the ratio equal to 0. So in order for it to be equal to 0, the numerator has to equal 0. So x minus 5 equals 0, x equals 5. So that is the value that will make it equal to 0. Now, to determine if it's part of the solution set, we need to plug in 5 for x in the original equation. Okay, so there's the original equation. Do I have my such that? No, I don't. So I have to add the such that. We're going to do this over and over in this section. X equals 5. So you put the entire inequality in. It'll say true or false. It says true, therefore it is part of it. So is this value part of the solution set? Yes. Make sure you answer all the questions. Some people did not do that on the quiz. At what x value is the ratio undefined? There's your undefined right here. So x plus 3 equals 0. We talked about that in the last section, whenever the denominator equals a 0. So at x equals negative 3, it is undefined, so it is not part of the solution set. This x equals negative 3 is also called a critical value, which will come into play later on in this section of notes. Enter the ratio in your calculator, help determine the values of x that solve. Okay, so what we do here is we have a number line. Because of this way up here, greater than or equal to, that 5 will be colored in. Okay, so that's 5. Now you have to account for the critical value, which is negative 3. All right, so we put a little asterisk because that is the asterisk. Now we test areas, test zones. Remember we did this when we had the x squared. So we are going to the calculator. So bring this down again. And so we need to test the values. You need to test to the left of negative 3. So I'm going to test negative 5, enter. It says true. So we are going to put a T above this area. Now we need to test between the negative 3 and 6. So I'm bringing it down, and I try to use 0 whenever I can if it's in the interval. So it tells me false. So you put an F above that one. And then we bring it down again and test to the right of 5. So anything bigger than that. And it says true. So we had a true, false, true. Now remember, we looked at this in the past and I said it usually alternates. But we're going to see in this lesson that it doesn't always. Set builder notation. X such that x is less than negative 3. Or x is greater than or equal to 5. That's your set builder notation. They get a little more complicated when we have polynomials in the numerator that have a power of 2 or higher, because then we have to factor. So solve the rational inequality. Now what we have to consider is where it is undefined. So that means we have to take the x squared minus 6x plus 9, set it equal to 0, factor it, so it's x minus 3 equals 0. So x equals 3, that's your star, that's your critical value. You have to take that into consideration. Now, when we cross multiply these, look this, it gives you 0, so that's gone. And then we just have this times 1, so we have x squared plus 3x minus 4 equals 0. Change your inequality to an equal sign, because then we do the test zones. So then this factors to x plus 4, x minus 1, So x equals -4, x equals 1. Okay? When we do our number line to test this, here's your number line. We have -4, we have 1, and we have 3. They are not colored in because of this way up here, right there. It's a less than. Since it is not less than or equal to or greater than or equal to, we do not color in any of those circles. So to test, we have to go back to our calculator. All right, there's 4 test zones. 1, 2, 3, 4. Now I'm going to my calculator. So if you want to put the T and F above them, I'm not going to go back and forth. I'll just put the T and F's at the end. So I go to my calculator. Okay, and I need to test to the left of -4, so I'm going to test -5. Enter. That says false. Then I'm going to bring it down. I'm going to test between -4 and 1, so I'm going to test -2. True. Okay, oh, I should have tested 0. Oh well. Bring it down again. I'm testing between 1 and 2, so I am testing 2, and that says false. And then one more area to test. I am testing to the right of 3. So anything, 25, doesn't matter as long as it's greater than 3. And there's a false again. So what do we have? We have a false, a true, a false, and a false. So you see, this is an example where it does not alternate. So you have to test it. And it usually occurs, or it might occur during or by the critical value. So be very, very careful of that. Now it says to state the solution either in interval notation or set builder notation. Okay? So it doesn't matter. This is your set builder. X such that -4 less than X less than 1, like that. Interval, and then that's your set builder. Sorry, interval is -4, 1, like that. Okay? Parentheses because neither one is included in the solution. Okay. Next one now, you might have something that does not equal 0. Okay, or less than or equal to 0. So you have a number in this case. What to look at? Look at that right there. Okay. See the less than or equal to. Okay. Undefined over here on the side. X minus 8 equals 0. X cannot equal 8. This is my asterisk because that is my critical value. Same process, put the 5 over 1, cross multiply, but this time it does not cancel. So we have a 5x minus 8 equals x. Remember, make it an equal sign. So we have 5x minus 40 equals x. Bring this over, bring the 4x equals 40, x equals 10. So these are the two values you're going to test. And we have 8 and we have 10. Now remember, up here, okay, was the equal to, so we can shade in the 10. Do not ever shade in the critical value number. Okay, so here is a picture of the calculator checking the values. The first one, where x is equal to 0, that's less than 8. The 9 is between 8 and 10. The 15 is to the right of 10. So in this case, it goes true, false, true. So we have a true, false, true. And I don't care what you use. 8, 10, like that. I'll show you that way. Oh, I'm sorry. Silly me. All right, because I thought the false. So true means it's good. So we have negative infinity. I hope I didn't screw too many of you up there. I'm sorry. Negative infinity to 8, union. There's your 10 to infinity. After I did it, I said, oh, no. All right, so I apologize. Okay. So there you go. There's your notation to show the solution. Now, the last one is the most complicated. So what we need to do, of course, the first thing is look where it's undefined. So we had to take into consideration the x and the x plus 3. So x equals 0, that's the first one. X plus 3 equals 0, so x equals -3, that's the second one. This has really got a lot going on. So we're back to having multiple fractions, denominators, so we have to have the LCD. Some of you are having a little trouble with the LCD. Just keep practicing with it. You will get better at it. You have to represent the 2, you have to represent the x, and you have to represent the x plus 3. Everything has to be represented. So in the first one, the x cancels, so I have the x minus 1 times everything that's left in the LCD, so it's a 2 and an x plus 3. Don't worry about the order right now. Now we have an x plus 2. The x plus 3 cancels, so we have a 2x. Equals, remember, we'll just set it equal. 2 cancels, so remember there's a 3, and we have an x plus 3. Okay? So when you send all this through, if you want to do these two first, all right, put the 2 out here, we have an x squared plus 2x minus 3, okay, plus this 2 will go through here. 2x squared plus 4x equals this 3x is going to go through. 3x squared plus 9x. We have got a busy problem here. Then this 2 has to go to every single term. So we have a 2x squared plus 4x minus 3 plus 2x squared plus 4x equals 3x squared plus 9x. Pause it wherever you need to, because I know I have a lot going on. Now I'm going to put a different color on here for you. Okay? 2x squared, 3x squared. These two combine to give you 4x squared. Bring this over, and I'm going to be left with x squared. Just the x's. 4x plus 4x is 8x. This 9x comes over. 8x minus 9x is negative x. Okay, and then what do we have? We have, right here. See that right there? My gosh, I don't know. It's late in the day. Minus 6, okay? Because this 2 has to go to the negative 3. All right, so a minus 6 equals 0. I don't have time to redo the lesson, so, all right, and we have an x and an x, minus 3 plus 2 equals 0, so we have x equals 3, x equals negative 2. Okay, so we have a lot of stuff going on. Are you ready for this? We have to make sure we take into consideration everything on the number line. What does that mean? That means we have to do undefined and the solutions. So we have a negative 2, we have a 3, we have a 0, we have a negative 3. So negative 3, which was one of our critical values, negative 2, and then we have 0, and we have 3. Thank goodness this is a less than. Okay, so we don't have to color in any of them. Now, you're going to have to take it for granted here. Okay, I'm doing it for you. It's a false, it's a true, it's a false, it's a true, it's a false. That's just putting it all in the calculator, the whole entire original expression. Okay, so that's what you get. And you have to take the time to do this. Some of you are skipping steps. You know who you are. And it hurts you, okay, so we don't want to skip steps. So negative 3, negative 2, union, 0, 3. Okay, that's your solution. And oh my heavens, that's the last video for a little while, because now we have the benchmark next week, and benchmark review, and then spring break. So this will be it. Okay, for a little while. So I will see you in class. See you.